Good day, grade 12s, and welcome to another physical sciences lesson. We're going to do some more revision on organic chem today, but as always, before we start, I am going to pop the Google Drive link in the Q&A for you. Just give me a second. My computer is decidedly slow today. I think it realizes that weekend is near. Right. There goes the drive for you guys. And again, before we start, let's make sure we all have the link for tomorrow. And there goes the link for you guys too. All right, hello guys, Wade, Kyle, welcome. Good to see my familiar faces. Awesomeness. All right, guys, so today we are going to do organic chem, and I warned you guys that we are going to be doing the reactions, okay? And I know this is a scary bit. I get it, okay? I also used to really struggle with this. So before we start, I'm going to take you to the document that I have lined up, okay? Whoops, give me a second, I'll move that out now. There we go, that's better. No, that's not what I wanted. That's better. Okay, so I'm going to take you guys to the document I've got lined up. This document is in the drive for you, okay? It says 20, it's got 12 physical sciences, and then it says 2304, and I labeled it as a flow diagram. Okay, so what I did in this is I tabulated for you the reaction conditions that you need to know. So we've got addition reactions, hydrohalogenation, halogenation, hydration, and hydrogenation, and we have each of those reaction conditions attached. Then we have elimination reactions. So the opposite of hydrohalogenation is dehydrohalogenation, okay? The opposite of hydration is dehydration, okay? And then we also have cracking. We have thermal cracking and catalytic cracking. Okay, then we have our substitution reactions, and the ones I didn't put on here was esters because we looked at that yesterday, and combustion. Okay, but I have them in this flow diagram over here. Okay, at the bottom you'll find a key so that you know what color arrow represents what type of reaction, okay? And I just gave you a very basic flow diagram of all the reactions that you could be asked. Okay, guys? Again, this is a summary of all the reactions. This is not meant to take away from you studying each individual reaction. But sometimes I find it helpful to have a flow diagram like this and to have the reaction conditions tabulated like this so that you have a singular place to go to for all of these informations. Okay, so I put as much information in here as possible for you, all right? Yeah, so I hope this helps a little bit, okay? But again, this is not meant to substitute the full studying of the hydrohalogenation and the full studying of halogenation. Okay, guys? So just a note for you on that. I hope this helps, okay? Like I say, this is one topic I used to really struggle with. Really, like I know how much info is in here. Okay, so I gave you this, but now we are going to look at a past paper, okay? So the past paper I chose, oops, is November 2017, paper 2, question 4, okay? And this flow diagram that you're going to get here is very typical of the questions that you will get at the end of the year, okay? They like doing a flow diagram like this, okay? And I think sometimes if you're not used to seeing things in a flow diagram, it makes life quite hard, okay? So get used to seeing them in a flow diagram like this, okay? Everybody still okay? Right. I'm now going to switch over to the whiteboard so that we can do some serious scribbling, right? So here is the flow diagram. We've got compound P. Oh, that's an organic alcohol. There it is, OH. And they say P is used to produce other organic compounds. Okay. A, B, C, D, and E represent the reactions. Make very sure you know what is the difference between the reaction and the compound formed. Okay, so it's always worth taking some time at the beginning of these questions to just orientate yourself. B, A, C, D, and E, these are the reactions happening. P, Y, X, and Z, those are the compounds that are formed. Okay. Now, sometimes with some questions, I like to answer like the little missing links here before I even look at the questions, okay? Sometimes I prefer to look at the questions because sometimes they're sneaky. Sometimes they give you all of these bits and then they don't even ask you what is compound Z, okay? And with reactions, they tend to do that, okay? With reactions, with this question in organic chemistry, they tend to put a lot of stuff in here that you are not going to have to answer, okay? And so for the sake of time, because remember, the question papers are set up that you have 1,2 minutes for each one mark of questions. Okay, you have 118 minutes to answer 150 marks. All right, so in a situation like this, I would not plan out the whole thing first and then look at the questions. So let's do that. And I'm warning you, okay, I am going to take you back to the Word document periodically, just so that we can see how everything fits back together. Okay, I hope that's okay with everybody. You guys are ridiculously quiet in that chat. Don't like it. Come on. Okay, so here are our reactions. Let's look at the questions. They want to know, is compound P a primary, secondary, or tertiary alcohol, and give a reason for your answer. Okay, now this information that they're asking from us, I did not put into the block of reactions, okay, because that has not got to do with reactions, but it's got to do with the basic theory of each homologous series, okay? And this is something you have to be ready for, okay? They do this in organic chemistry. You're going to get a question in the question about reactions that's got to do with IUPAC naming or with basics, okay? It is going to happen. So let's look. They want to know what type of alcohol is compound P. We've got a primary, secondary, and tertiary, okay? So we need to look at the carbon that the OH group is attached to, okay? So here is our OH group. Our OH group is attached to this carbon over here. I might delete the writing that I'm doing now, but I just want us to have like a point of reference. Here we go. Right, so we are looking at that carbon. The facts about this carbon will tell us what type of alcohol we're dealing with. This carbon here is attached to 2 other carbons, okay? That means that this carbon is a secondary carbon, okay? And therefore, because the alcohol group is attached to a secondary carbon, we refer to this as a secondary alcohol. I'm going to say that again. When we need to know whether it's a primary, secondary, or tertiary alcohol, we find the OH group, we find the alcohol group, and we find the carbon that it is attached to. Then we look how many carbons is directly attached to this one. 1, 2. There are 2 carbons attached to this oak here. That means that this is a secondary carbon. Because the OH is attached to a secondary carbon, we refer to this as a secondary alcohol. Okay, so just to think about what it would have been if it was primary or tertiary. If it was a primary carbon, we would have been looking at this carbon here at the end. The carbon here at the end is only attached to 1 other carbon. So when I have an alcohol group on the first or the last carbon, 99.9% of the times, it is a primary alcohol. If this hydrogen here was replaced by a methyl group, then this carbon would have been attached to 1, 2, 3 other carbons, and I would have been dealing with a tertiary alcohol. Okay, I hope that makes sense to you. I hope the fact that you can remember that, because it is, if you understand the biomechanics of it, then it's actually not quite that bad. Okay, so we've now that's fine. So let's find some space to write. Let's do it over here, shall we? Okay, and of course I forgot what the question number is, but you guys know me well enough to know that that's not unusual, 4.1. Okay, so we have established that this is a secondary alcohol, so that gives you 1 mark. Your second mark you're going to get by saying the OH is attached to a secondary carbon. All right, guys, and it really is as easy as that. All right, not much to that. That is theory. Okay. 4.2, write down the type of elimination reaction represented by A. Now, this is on the one hand a really nice way of asking it. On the other hand, this quite limits you, okay? Because they're already telling you it is an elimination reaction. So you kind of know what your boundaries are. You know which elimination reactions you can deal with, okay? Which really does help. On the other hand, you have to know all your elimination reactions exactly by name to be able to answer this question. Okay, so let's have a look. We are looking for reaction A. Reaction A, I go from an alcohol to an alkene. That means that I'm removing the OH and the H, okay? And by the way, I'm going to remove that H because this H is at a party that's really bopping, okay? Guys, if you struggle to remember which H gets removed, hydrogens are the life of the party, okay? OH wants to take people home with him. Now, OH is going to ask this hydrogen, dude, will you come home with me? But this hydrogen is at a party where there are other hydrogens that's like really, it's pumping. If the OH asks this hydrogen on the other side of it to go home, you'll notice that there's much less of a party happening here. And so this hydrogen here will go home with the OH, where this hydrogen here is going to go, dude, like, you know, I'm happy. I want to stay. The party's pumping. Okay. So that's an easy way to remember which hydrogen will come off. Okay. So we've got the OH coming off and we've got the H coming off. So we effectively have water coming out. And what do we call it when we take water? Any elimination reaction generally starts with the word D. So we know it's got to be D something. We are taking water out. When we drink water, we hydrate ourselves. So we dehydrate. Okay. And when we refer to a reaction, we say dehydration. Okay, guys, not that hard. Just the basics that you need to keep in mind while working with this. Okay. 4.2.2, it's an addition reaction, and we're going to go and find letter B. Okay, that's a bit of a giveaway, Mark. Oh my goodness, if you know that A is dehydration, or dehydration, then B is simple. B is a no-brainer. Sure. See, I don't like questions like that because it means if you kind of get stuck on the one, then you're definitely not going to get the other one. But having said that, I find hydration and dehydration the easier of the reactions to deal with. Okay. Now we have to go elimination reaction represented by D. Cool. D is an elimination. We know this. They told us this. But now we've got this problem here. Hey, ma'am, I don't know what X is. Okay, fair enough. But if I have an OH and under the right conditions, I add an halo acid, in this case, HBr, okay, then this will end up being a substitution reaction, okay? And so I can, from that, figure out that compound X, I'm not going to be too specific, is going to be some or other haloalkane. Okay, this Br here is going to replace that OH, this H and that OH is going to form water, and the Br is going to replace that. So we're going to have an alkane with a halogen, so it is a haloalkane. Right. We know that D is elimination. They told us so. Okay, so when I take away halogen, I normally take away a halogen and its hydro. Okay, it's elimination. And so I can say this is oh goodness, halogenation. There we go. Big word, big word, big word. Okay, you guys still all right? This is still the basics. We're still okay. Oh, guys, you scare me when I can't see you. Sure, you scare me when I can't see you. Okay. Oh, now we start talking about reactions and reaction conditions. Okay. We're talking about reaction C, and we get told sodium hydroxide gets used. Just so I don't get confused, we have sodium hydroxide. Okay. Sodium hydroxide is a strong base. Okay. Let's have a look at reaction C. Okay. Reaction C is when we go from a haloalkane back to an alcohol. Okay. So we've got the haloalkane and we substitute and we go back to the alcohol. Let's have a quick look. It's a substitution and we go from a haloalkane to an alcohol. So we know that we have to have ethanol as a solvent and we need a strong but dilute base. We also need heat. Okay, so strong base, ethanol solvent, and heat. They want to know what type of reaction takes place here. Now, you could get away with only writing substitution, but because this is a matric paper, I would be slightly more careful. I see questions. Keziah, Sean, Kyle, I've been trying to avoid rate of reaction like a beast, but if you guys want to attempt it, we can do it next week. I'm quite happy for us to attempt it next week. Matthew, the difference between dehalogenation and dehydrohalogenation, we don't actually deal with dehalogenation on school level, okay? Mpilo, I see your question, I'll go back to it, okay? We call it dehydrohalogenation because from the haloalkane, on this haloalkane, there's only going to be one halogen, okay? Only one halogen, Br. And so for me to take the halogen off, I have to take something with it. And in this situation, it has to be a hydrogen. And that's why we refer to it as dehydro. Whoops. Actually, let me just get that out of the way. There we go. Dehydrohalogenation. Okay. It is possible if you have an haloalkane and there's more than one halogen on there. Under the right conditions, it is possible to take both of the halogens off. But in this situation, because there is only one, when I take that halogen off, I have to take a hydrogen off too. Okay. Let me just see that I've got everybody. So Carl, you need to tell me if you are brave enough for rate of reactions, okay? Mpilo, 4.2.3. Okay. 4.2.3 wants to know reaction D, okay? And they tell us that it is an elimination reaction. If I take you back to my little table, elimination, we have dehydrohalogenation, we have dehydration, and then we have the thermal cracking. Okay, so it either right now, because it's a reversible reaction, thermal cracking isn't, it's either going to have to be dehydrohalogenation or it is going to have to be dehydration. Okay, now we have to go back and we have to see what we have and what we start off with and what we finish. So I'm looking for reaction number D. D here. Okay, got it? To know what oops, my bad, sorry guys. To know what reaction D is, I need to know what compound is formed here, which is mean. Okay, this is like really a mean question. So now I have to go back and I see that compound X is formed when an alcohol reacts with hydrobromic acid or hydrogen bromide. Okay, now because there's that Br, I am going to assume, which I know is dangerous. Okay, I'm not saying assuming is not dangerous. I'm going to assume that the Br is going to replace the alcohol. And I assume that because when I look at my possible substitution reactions, I have interconversion between an alcohol and an haloalkane, interconversion between a haloalkane and an alcohol, or I can take an alkane and substitute it. But I know that I started with an alcohol, okay? And the alcohol forms a haloalkane, okay? So now I can assume that compound X is a haloalkane, okay? This Br here would have replaced this OH, and the OH and that H that gets left over there will form water. Okay, so now I know that compound X is a haloalkane. But that's not the question. The question is, what is D? Okay, so D is an elimination reaction. They said so, elimination reaction. And D forces a haloalkane to become an alkene. Okay, so what I am taking off is a halogen, but the halogen needs a friend, and so it has to take a hydrogen home with it. Okay, does that make more sense in terms of why it is dehydrohalogenation and not simply dehalogenation? Okay, like I say, guys, we don't have, there is just dehalogenation. I'm not saying it never occurs. It's like Matthew asked me the other day, ma'am, do we get organic compounds with nitrogens in? Yes, of course we do. But the time and limit and scope that we have for grade 12 limits us to certain things. Okay. And so just be very mindful of what you can, what reactions can happen. And that's why I put together, one, the reaction conditions for you guys, as well as a flow diagram. Okay, these are the reactions that you can deal with. They cannot examine you on a reaction that is not on here. Okay, they are not allowed to, it is not in the CAPS document. They are very, very strict on examiners in terms of that. Okay, so if you can make sure you know which reactions you could get, then you should be okay. All right. Okay, Carl, I get it. Rate of reaction next week. You guys are pushing me out my comfort zone. Okay. I purposefully didn't do rate of reaction this week because it is so tough. Okay. Because it's a really tough section to teach as well as to understand. Okay. So I didn't want to completely push you guys out of your comfort zone, which is why I thought going back to organic chemistry and then giving you fertilizers would be like a good way of doing. But now I can see some of your teachers are already pushing that boundary, okay? And Carl and Sean, I completely understand why you guys would be confused and scared of it. Okay, so what I'll do, it's a nice long weekend, because remember, Monday's a public holiday, no? Don't forget that. I will go and sit and I will do my absolute best to get you guys solid notes on rate of reaction and acids and bases and. Even if we don't get to it, that you have notes for it. Okay, that is my promise to you. Okay, like I say, the only reason I've been avoiding it is because it's so tough. And I didn't want to expose you guys to that in this situation. Okay, that's the only reason I've been avoiding it. Okay, guys, let's get back to this question. All right. So, what type of reaction takes place at C? C, when I go from a haloalkane to a alcohol. Now again, you could get away with simply saying it is a substitution reaction, okay? You could get away with doing that. I strongly recommend, however, that you also add it is interconversion between haloalkane and alcohol. Again, okay, if you're looking at me going, sure, man, that's a lot to write. It's 1 mark, okay? So the chances are you would get the mark if you simply wrote substitution, okay? I just always err on the side of caution. Okay, you never know what that memo says. Okay, state the 2 reaction conditions for this reaction. Okay, now they've already given you one. They've been so nice. You just need to be able to like catch it on the read. Okay, so let's quickly look so that I don't lead you astray. We are going from a haloalkane to an alcohol. So we need a strong dilute base and we need heat. So those are the 2 reaction conditions you are going to give them. You are going to say strong dilute base and heat. Okay. If you want to say to them that you're using aqueous sodium hydroxide, you're more than welcome to, okay? But I wouldn't, because they're asking for reaction conditions. Okay, right. Write down the IUPAC name of compound X. Okay, to do this, I'm going to zoom out and I'm going to write it over here, okay? Because we just need to keep half an eye on what we start with, okay? I will zoom back in again, I promise. Okay, so what ends up happening is this Br and that OH change places. Okay, so the compound that forms has got 1, 2, 3, 4 carbons, and instead of an OH, it has a Br, and nothing else changes. I still want an H stand. Okay. So now I know what compound X looks like. And now I can go and figure out compound X's IUPAC name. Okay. If you struggle with IUPAC naming, don't panic. Just have a system. The first thing you do, you count the number of carbons in the longest chain that includes the functional group. Okay. Here we don't have an external functional group like an OH or a double bond O or any of those. Okay. So we only have to find the longest carbon chain. Luckily, this one's short. 1, 2, 3, 4. Okay. 1, 2, 3, and 4. So when we're working with 4 carbons, it's but something, button something. There's only single bonds, which means I can say this is butane. Fantastic. Okay. Now we have to deal with the Br. And luckily, there's only one. Okay. There's nothing else added to this molecule that we have to go, oh my goodness, which way do I count? You only have to worry about the Br. If we count from left to right, then it's 1, 2, 3, and 4. If we count from right to left, then it's 1, 2, 3, and 4. So our possible names here for the front end would be 3-bromo-butane or 2-bromo-butane. Now the IUPAC rule says we try to put the substituents, huge word, it means the added stuff. We try and put the added extras, the things that are not part of the longest carbon chain, on the lowest possible number. So the correct IUPAC name for this guy would be 2-bromo-butane. There's only one bromo, so there's only going to be one number. Okay, so this one isn't that bad. I think the part that would have scared me on this is that there are so many questions about that section that you kind of have to like really keep your wits about you. Sorry guys, I've got a little puppy shouting in my ear. It's okay. Gareth is going to go and save her. Okay. Sorry guys, I live like, I don't have a zoo, but it sometimes feels that way. Pumpkin. Sorry guys. Close. Reopen. Let's try again. There we go. Okay. Because I had 2-bromo in my head because I was like, I mustn't forget on which carbon the brome is. 2-bromo-butane. Okay, guys, you must make sure that you know your met-et-probit. I see you guys got there before me. Kyle, yes, just remember you have to label where the bromo is. Okay, your name is correct, bromobutane, you are correct, but you have to tell them where the bromo. Okay, remember, chemist people are a bit weird. Okay, like really weird. So you need to treat them like weird people. Okay, so you also need to treat your examiners like weird people. Okay, so you have to tell them where the bromo is. Okay. Right, got it. I'm happy that you guys are working with me. I'm very, very happy that you can name these things. It's a big chunk. If you can name them, then it makes life a lot easier and you can be a lot calmer about your exams. Okay. Right, guys, we've got about 5 minutes left. Let's see what's left to tackle. Okay, we've got reaction D, structural formula for E with our all balanced, and the IUPAC name of Z. Let's quickly look. D, where's D? Over there, D. Okay. So they want to know the inorganic reactant needed for reaction D. That is code for what is the catalyst. Okay, so they want the catalyst. We said when we go dehydrohalogenation, we need a concentrated strong base. Okay. If you look, when you take things away, there's only 2 places where you need a base. Okay. It's with the halos. It's when you remove the hydrohalo. Okay. Can you see that? And add something on or eliminate it. So if I want to make it an alcohol, I need a dilute base because I need lots of OHs. I need lots of water. That's how I get the alcohol. But if I just want to take the hydrohalo off, I don't want to add anything, then I need a concentrated strong base. Okay. So they want to know the formula of an inorganic reaction, inorganic reactant needed for D. So you can choose any strong base, okay? You could go KOH, you could go NOH, you could go, now my thoughts have run away, okay? So any of the group 1 metals with an OH. Okay, that will get you the marks. Okay, next up, structural formula. Guys, I'm going to move over a little bit because I'm like running past that thing there. Structural formula, balance equation for E. E is an alkene, and I put H's on there. Whoa, so this is hydrogenation. I add hydrogens to the nation. Okay. So I've got alkene. Now, which alkene do I have? It comes from there, so it has to have 1, 2, 3, 4. Okay. This is a very mean question because you have to do this elimination correctly. Okay. Again, this OH, when it eliminates, is going to take that hydrogen. So the alkene I start with, and that's why I think this is a sneaky question, the alkene I start with has got the double bond there because the OH was removed from there and the hydrogen was removed from there. Why? Because this carbon has 3 hydrogens. So none of those hydrogens want to go home yet. The party is pumping. Okay? So I'm going to draw my alkene like this.
Teacher, we've got 5 minutes left.
Thank you, sir. Next up, H2. They told me that. On the arrow, what do we add? The catalyst. Okay. And now it's super easy, guys. Like, oh, no, come back. Here we go. I'm going to write it at the bottom because clever me, you know, you saw my board skills are not great, guys. We know this. Okay. And now it's easy. Okay. Now we have butane. To save some time, but you're not allowed to do this because I want to get to the last question. We have 5 minutes left. 2 minutes left. I am not going to draw the hydrogens. Okay. I'm sorry, excuse me. Ma'am, I lost marks because I didn't include concentrated. Yes, you can write that, okay? But they're not exactly asking, they're just asking for the formula, okay? If you had to give the reaction conditions, then I would say absolutely yes, okay? But again, guys, I've told you this, I would mark it like that too if I marked it at school, okay? Because you force the kids to think better. Last one, IUPAC name of Z. Last one, we're almost there. Oh, really? Seriously? That easy? Sure. 1, 2, 3, 4. Nothing else. So we have butane. That was almost too easy, hey guys? Sure. Okay. Before we conclude, quicks in this chat. I'm going to give you guys the Google link again for a last time, the drive, share, and post. And tomorrow's link and copy. Oh, not that one. And paste. Okay, so you have the drive and you have the team for tomorrow. Sean and Kyle clearly have started with rated reactions. So I'm still going to give you guys fertilizers, the notes, okay? I'm going to apologize beforehand because I have them handwritten. So I'm going to save a little bit of time and I'm going to post the handwritten stuff for you, if that's okay with you. Then, seeing as you guys are asking, tomorrow I will start with rate of reactions, okay? I hope that helps, okay? I need you guys to bring your questions because obviously I'm going to be a little bit behind you. So go back to the beginning and see what has been asked. Okay, guys? Deal. I can do that for you. Sharp. Awesome. Guys, I will see you tomorrow. Please join. Tomorrow's Friday. We're going to have an awesome time. Okay? And then you have a long weekend. I hope you have a fantastic day. I hope you are studying. I hope you are being productive. And I'll see you guys again tomorrow. Bye.